Hey guys, today we're going to do section 2 of chapter 9 for FST, which is called Graphs of Polynomial Functions. So in this section we have a ton of vocabulary and we're just going to talk about different, let's just say, things that we know about polynomial functions. So the first two vocab words are maximum and minimum values. So maximum value is the largest value of a function in the range, and minimum value is the smallest value of the function in the range. And we've seen maximums and minimums before. They're not any different. It's just looking at that function. What is the maximum amount that you could get out, or what is the minimum amount that you could get out? Notice that it says range. That means you're talking about y values. Okay, we also have extreme values, or extrema, and that is the max or min of a function. So extreme values, or better referred to as extrema, they're just talking about your maximum and minimum values. We also have what's called relative maximum, relative minimum, and relative extremum. So relative maximum and relative extremum are just talking about within a certain specific smaller subset of the range. So we're not talking about over the entire function. We're just talking about within one small area of the function, what is that maximum value or what is that minimum value. This is kind of weird because you're kind of like, why do I care? But the thing is that with polynomial functions, they go a lot like this. Okay, so we can isolate those curves and we can talk about within just a small set of the curves, where are my values for my minimums and maximums occurring. Okay, and then relative extremum, of course, that's just talking about the minimums and maximums within that smaller subset of the range. We also have the zeros or roots of a polynomial function, and those are just values where p of x equals 0. Okay, we call them zeros or roots. They're just places where your function is crossing the x-axis, essentially, so x-intercepts. A function is positive on an interval when the values of the dependent variable are positive. So when I talk about areas where my graph is positive, I'm just looking at the graph and determining when it is above the x-axis. So where are my values positive? So I'm talking about my y values and I'm just looking for positive y values. And same thing with negative. Negative values are just when the graph is negative. So where on my graph do my y values become negative numbers? That's it. So again, you're just looking for places where the graph is below the x-axis. A function is considered to be increasing on an interval if for any 2 points on that interval, the slope between them is positive. So remember that when I'm talking about a positive slope, I'm talking about a slope like this. This is my positive slope. So as my x is increasing, my y is also increasing. A function is decreasing on an interval if for any 2 points on the interval, the slope between them is negative. So if you have a negative slope, remember that looks like this. So as your x is increasing, your y values are decreasing. So any place where you have a negative slope, that would be considered decreasing. Alright, so now what we're going to do is we're going to do some example problems. And I will just kind of show you exactly how I would do one of these problems using my graphing calculator. So on my graphing calculator, I'm going to go to my y equals, and I'm going to type in 3x cubed minus 2x plus 5. Okay, then I'm going to hit graph, and I get a function here, and I'm just going to kind of sketch out what I see. I did a window of negative 10 to 10, negative 10 to 10, and my function looks something like this. Okay. So looking at that function, I want to be able to find a relative minimum and a relative maximum. Okay, so if I were to kind of zoom in a little bit closer on this area here, I could see that right here I've got a maximum point. Okay, it curves up and then it comes back down. So right there is going to be a relative maximum, and right here is going to be a relative minimum. Notice that this is why relative extrema are important, because technically the maximum and minimum of this function is that there is none, because this continues infinitely in the negative direction and this continues infinitely in the positive direction. So the only way we can talk about these maximums and minimums are using relative extrema instead of actual extrema. So if I want to find this point here, what I'm going to do is I'm going to go on my graphing calculator and I'm going to hit second calc, and there's a spot there that says maximum. So I'm going to type that in. I'm going to hit maximum. Then it asks me for a left bound, so I'm going to scroll to the left of this point here where I think my maximum is. And then I'm going to hit enter. And then it asks me for a right bound, so I'm going to scroll to the right of that point and hit enter. And then you can hit enter again to take a guess, and it'll tell you that your maximum is when x equals negative 0.47. So I'm going to keep track of this point here on my graph. So this is negative 0.47, comma, 5.63. And I'm just going to keep track of that on my graph so that I can come back and refer to it and I don't have to just find it every time. So my relative maximum is going to be the point negative 0.47, comma, 5.63. Okay, now I'm going to do the same thing for the relative minimum. So on my graphing calculator, I'm going to go to second trace. I'm going to go to minimum. It'll ask me for a left bound, so I go to the left of my minimum. It'll ask me for a right bound, so I go to the right of my minimum. And then I hit enter, and it gives me a minimum at 0.47, comma, 4.37. So over here, at 0.47, comma, 4.37. Okay. Next up, it asks me for my zeros. So the zeros of my function are the places where it crosses the x-axis. So you can see here that I'm only going to have one zero, and it's going to be right here. So to find that on my calculator, I can hit second trace. Number 2 is 0, so I'm going to hit that. And then it asks me for a left bound, so I'm going to arrow over to the left of my 0. And then I'm going to arrow to the right of my 0 and hit enter. And I get that my 0 is at the point negative 1.37, comma, 0. Okay, so my 0 is at negative 1.37. Alright, so now if I want to find intervals where the function is increasing, remember, increasing is talking about where I have a positive slope. So, looking for the places where I have a positive slope, all the way up into this maximum, I have a positive slope, but right in between my maximum and my minimum, I have a negative slope. And then, after my minimum, I also have a positive slope. So I'm going to have two intervals where my function is increasing. It is going to go from negative infinity up to negative 0.47, and then from 0.47 up to infinity. So I can say x is less than negative 0.47 and x is greater than 0.47. So those are the intervals where my function is increasing. So then the intervals where my function is decreasing, that's just going to be this area here where I had a negative slope. So that is when x is between negative 0.47 and 0.47. Notice that I'm not making these inclusive. I'm just making them strictly less than or strictly greater than, because at these points here, the function is not actually increasing or decreasing. Okay, now we've got intervals where the function is positive. So remember, where the function is positive is talking about places where the function is above the x-axis. So if I look here, anywhere above this 0 here is going to be above the x-axis. So that's all of my x values that are greater than negative 1.37. So I can say x is greater than negative 1.37. And where the function is negative, well, that's going to be anything less than negative 1.37. Okay, and that's everything for this section. I would recommend that for all of these problems, you guys draw out a graph and label it, and then you can just kind of trace over the areas that would apply to increasing, decreasing, positive or negative, and you can come up with your intervals that way.